Venus is one of the easiest objects to spot in the sky. Bright, beautiful, almost familiar. But for most of human history, Venus was a planet with no face. Its surface was completely hidden behind clouds so thick that normal light simply couldn't reach the ground. No clear photos, no true views, just guesses, sketches, and speculation. Then the Cold War era of space exploration turned Venus into a brutal proving ground. This wasn't Mars, where machines can crawl around for years. Venus was the kind of place where a mission plan basically meant drop a robot into an oven and hope it survives long enough to send something back. The Soviet Union kept attempting it anyway. Between 1961 and 1984, they sent more than a dozen probes toward Venus. Many failed, some never arrived, some burned up, and others didn't survive the descent. But in 1975, everything changed. Venera 9 reached the surface and lasted for roughly 50 minutes, long enough to transmit the first image ever sent from the surface of another planet. The photo was black and white, rough, and slightly distorted. It didn't look like science fiction. It looked like a harsh, rocky worksite under a heavy sky. But it was real, and that was the shock. Only days later, Venera 10 landed about 2,200 kilometers away and survived about 65 minutes, sending another grim view, fractured slabs of stone under hazy light. And then came 1982, Venera 13 and Venera 14, missions that made Venus feel even more unsettling. Venera 13 returned color, recorded sound, drilled into the ground, and analyzed the soil. The sky came through as a deep, sickly yellow, likely shaped by sulfur-rich gases. The surface looked like it was covered in flat, broken plates, like crust that had baked and cracked under pressure. Those early landers didn't deliver pretty. They delivered reality. Venus is harsh, distorted, and hostile. And yet, for brief moments, humanity managed to steal a view of a world that normally refuses to be seen. If you try to photograph Venus from space the way we photograph Mars, you hit the same wall every time. Clouds. Venus is wrapped in layers so dense, reflective, and chemically aggressive that visible light can't show you the ground. From orbit, the planet looks smooth and bright, almost featureless, because what you're seeing is sunlight bouncing off the cloud tops, not the surface. So scientists changed the approach. Instead of using light, they used radar. Radar can cut through the clouds. You send radio waves down, they bounce off the surface, and you rebuild the echoes into maps of texture and shape. That method reached its full power with NASA's Magellan mission. Magellan launched in 1989, entered orbit around Venus in 1990, and spent about 4 years doing one thing obsessively: mapping the planet through the clouds with synthetic aperture radar. It wasn't chasing postcard photos. It was building a true, global portrait of Venus, based on measurements, not imagination. The results were incredible. Magellan mapped roughly 98% of Venus's surface, down to about 100 meters per pixel. It revealed massive shield volcanoes, vast lava plains, and strange geological structures, including wide pancake domes. It showed elevated regions like Ishtar Terra and Aphrodite Terra rising up to around 11 kilometers above the lowlands. And then came one of the biggest surprises. Based on crater counts, Venus's surface appeared geologically young, possibly only 300 to 500 million years old. On a planetary timescale, that's recent. It suggested Venus may have resurfaced itself on a massive scale, wiping large areas clean, like a planet restarting its crust. Magellan's radar data also became the foundation for 3D reconstructions, maps converted into topography and lighting simulations that allowed scientists to fly over Venus virtually. In 1994, the mission ended with a controlled plunge into Venus's atmosphere. But its message was permanent. Beneath the clouds, Venus isn't smooth or calm. It's scarred, volcanic, and shaped by extreme forces. Here's where the story gets almost unbelievable. Scientists didn't only map Venus from orbit. They also mapped it from Earth. The idea sounds impossible at first, but it's real. Powerful radio telescopes transmitted radar pulses toward Venus and listened for the echo that bounced back. Arecibo was famous for this kind of work, and it was often paired with receivers like the Green Bank telescope. This technique is simple in concept and brutally difficult in practice. The signal has to travel millions of kilometers, hit the planet, scatter, and return so weak that it's almost lost in noise. You're basically trying to detect a whisper that's crossed space twice. But it worked well enough to produce detailed radar maps, showing major features like ridges, volcanoes, plains, and craters. An Earth-based radar offered something Magellan couldn't: repeat observations over many years. That means scientists could compare old scans and new scans, looking for changes. Over time, certain areas didn't match perfectly, not just tiny brightness shifts. In some places, there were hints consistent with surface changes, possible collapses, or textures that looked like they might have been altered by recent activity. A region often discussed in this context is Inoplancia, described as a vast lowland scattered with volcanic features. Comparisons between radar data sets, such as those from 2012 and 2020, suggested changes that didn't easily fit the idea of a completely dormant world. Even more interesting, these Earth-based radar maps often agreed with Magellan. Rough areas tended to reflect radar strongly in both data sets. Smoother plains looked duller in both. Different tools, different decades, pointing toward the same underlying reality. So even without seeing Venus in the way we see Mars, scientists have still managed to map it, track it, and possibly even detect change, simply by bouncing radio waves off the planet and listening carefully to what comes back. Venus is the third brightest object in our sky after the Sun and the Moon. That's why people mistake it for an aircraft, a drone, or even a UFO. But that brightness is deceptive. What you're seeing is sunlight reflected from clouds, not the surface. That's why it caused such a reaction when NASA's Parker Solar Probe captured images that appeared to show Venus's surface in what looks like visible light. Parker wasn't designed for Venus. It was built to study the Sun, diving into the solar corona and surviving conditions that would destroy most spacecraft. To achieve its orbit, Parker used Venus for gravity assists, 7 flybys in total. During a 2020 flyby, engineers aimed Parker's WSBR camera toward Venus. It wasn't optimized for planetary imaging. Expectations were low, but the images captured something unexpected: faint surface features visible through the haze, especially on the night side, where the planet's scorching surface emits thermal glow. This wasn't reflected sunlight. It was heat, radiated by the ground itself, showing up in a narrow band that blends near-infrared into visible wavelengths. The images weren't sharp, and they weren't pretty, but they revealed real patterns: plains and highlands emerging like ghost silhouettes. WSBR also captured a subtle atmospheric glow linked to oxygen high above Venus, useful for studying the upper atmosphere. The key point is this: a camera built to watch the Sun accidentally gave us a rare new way to glimpse Venus, without radar and without filters designed specifically for the planet. Then came evidence that pushed the idea of active Venus even further. In 2023, researchers reanalyzing old Magellan radar data reported something unusual: images of the same volcanic vent at a site called Mont Mons, described as one of Venus's tallest volcanoes, taken about 8 months apart, didn't look the same. The later view suggested the vent's shape may have changed, possibly from collapse, and radar signatures were consistent with fresh material on the floor, potentially lava. In 2024, further analysis using advanced processing across large sets of Magellan scans pointed to broader patterns: more volcanic features that appeared to show recent change, including places like Sif Mons and Niobe Planitia. Not live eruptions on camera, but before versus after differences that hint Venus may still be reshaping itself. If Venus is active, the implications are huge. Active volcanism means internal heat is still moving. It could help explain why Venus's atmosphere behaves so strangely, why certain gases fluctuate, and why the cloud layers show unusual features that still aren't fully understood. And now comes the next step: missions designed to turn hints into answers. NASA's Veritas and ESA's Envision, described as targeted for the early 2030s, are planned with high-resolution radar and spectroscopy to watch surface changes and search for signs of ongoing volcanism, flows, thermal anomalies, and possibly gas plumes. When you put everything together, Venera's surface panoramas, Magellan's near-global radar maps, Earth-based radar comparisons, and Parker's night-side glow, you get a clearer picture of the real Venus. not a CGI planet, not a filtered fantasy. A world that may still be active, still hot, and still changing beneath its clouds. So the real question isn't whether Venus looks alien. It's whether Venus is still alive, and how long it's been hiding that from us.